Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Welcome back. In this episode, we are going to be continuing the series by looking at animation states and how we can do some more advanced things with it. So to start off, we're going to be opening up our animation blueprint, and I have that one open here, and this is where we left off. Now, to illustrate the points we're going to be making, we're going to be adding a new state for jumping. So we'll just right click and add an animation state, and we'll call this one jumping. Now, what we want to do in this state is we want to obviously jump. And in the first episode, we created a animation sequence, which we called as jump. So we'll just hook that one in here. So we want to, at some point in time, cause the character to jump. Going back in our state machine here now, we need to somehow transition into jumping. And we can do this simply by going from idle, for example, into jumping. And we're going to be driving this transition by saying that we have jumped. And how we're going to be doing that is we're going to be going to our character. Let's see, where do I have our character? Is it in here? Yes, BP character. So we currently only have the input for moving right and left on this character, but now we're going to be adding some jumping. We should, and we will, go to project settings and set up an input for this. So we'll create an action mapping because we want to have something that fires once. So we'll call this jump. We can have spacebar be our default key for this, and we can close project settings. Now if we right click and we type in jump, we should get our action event jump, like so. And from here, what we want to do, we want to make use of the functionality that we get from our character and our character movement. And we'll just cause it to call the jump function on the character. This will, if we start playing, now cause our character from being on the ground to jumping up in the air, but the animation isn't playing. So we need to have some sort of way of communicating that this one needs to be playing now. We can have this information be done in a multitude of ways, but we're going to keep it simple to begin with. So in our character, we're going to be creating a variable. We'll call it jumping. And then we're just going to have it as, if we compile, it will be by default false. So we're going to be setting it to true. This way, whenever we press jump, we'll set this boolean to true. And then we can go to our animation blueprint and we can say that, well, we want to have our owning character. And then we need to have our actual blueprint character here, because that's where this variable exists, and this only returns an actor. So we could have gotten something like get or cast to BP character, and we don't have execution nodes in the blueprint. So what we could do here, for example, is right click and do a convert to pure cast. This is, however, not great, because every time we do this, we are essentially checking against our actor to see if it is of this character. It's a bit of an unnecessary cast. We don't want to cast. As a rule, we want to try and avoid casting as much as possible because it's too easy to lean on it. But there are times when casting makes sense. So what we'll do instead is that we'll go to our event graph, and we have an event called onInit. And from here we can do get owning actor. And we can do the cast over here. So we can say cast to BP character in my case, since that's what I have named it. And that means that when this animation blueprint is created or on its initialization, we do this check for our owning actor, we can cast it, and then we can save this for later. So we can promote this and call this player character or something like that. Character, there we go. So now we have this reference saved, which means that if we go to our state machine again, we can say, instead of getting owner actor here, we can just get our player character like so. Now that we have our player character, we can get our variable that says get jump. And if we scroll to the bottom, we should find it here, get jumping. And we can say that if it's true, we should be able to transition. So checking our character now, we press jump, and we can see that we actually enter into the animation. But you can see that now the animation repeatedly plays. And the reason for that is, of course, if we go to our animation blueprint and the state machine, is that we only enter this state. And then it's looping, so we never leave this state. So it might be good to actually add functionality to leave. So we'll add a transition back to idle here. And now we need to decide, how do we decide when we're no longer going to be playing the jumping animation? When have we landed, essentially? If we go to our character, in addition to having some fancy functionality here, we get some functionality with in conjunction with making use of this jump. So if we right click and type in on landed, this is an event that gets called when the character detects that it has landed. We can essentially say that we want to stop jumping when this happens. To make this a little bit more clean, we can also do an on jump. This event gets called when jump is called, which is what we have here, and we can drag this over here and have it instead be called from the on jump, like so. So it becomes a little bit more clean and understandable what's happening. So when jump is called, we set jumping. When we land, we set it to false. Now if we run, right, I didn't actually set it in the animation blueprint. Let's go back to the animation blueprint. So we go into the animation blueprint, we check get player character. We want to get the jump or jumping. And if this is not true, so not equal, no, not equal, sorry. We want to have a Boolean not node in this case. This one. So it will invert the jumping. Then we can say that we transition back, for example. This is one way to do it. And to show off that it works, we can just jump and you can see that we go back to idle when we land, essentially. So that's all good and fine like so. Another way we could have determined it, and this is a matter of personal preference really and what makes sense for your game, but our player character here currently has a movement component. So if we get character movement and then scroll to the bottom, we get the character movement, and from here we could check the is walking. Now this function will return if we are currently walking at any point in time, and this will be set to true in the case that we have landed. So you could also use this as your trigger for returning back to being idle. Just showing off that it works, you can see it does the same thing essentially. So make something that makes sense for you and doesn't make it cluttered with a lot of different variables essentially. Now, so we have this animation and we can see that if we play it, we have a bunch. It looks pretty good actually. It does a whole sequence of different things in this jump. But when this breaks down is when let's put in some basic shapes here. Let's put in a cube. Actually, let's put in a bunch of cubes. So I'll just hold down Alt and drag to make multiples. And we'll put 4 cubes on top of each other. That should be good enough, I think. So if we go up here and we press play, actually we need to make sure that these different boxes are also aligned. So we'll mark all of them, make sure that they have a Y value of 0. That's still not under the character. Is it because I moved the character? My character is at 120, so let's put the character at 0 as well. There we go. So now it's above it. So now if we're jumping up from this, you can see that we're doing that jumping animation. If we put ourselves on the edge and then jump and then fall down. It wasn't super clear. Let's try this again. We play again. So jump. You can see that it plays the animation and sort of prematurely ends before we land. And the reason for that is that our jump animation is actually fairly large or long. If we go to jump, we can see that it consists of 18, actually 19 with the 0 one, different sprites. And how this specific jump animation is set up is it actually has, if we open up the flipbook, we can see, and we pause this, we can see that it starts off with a sort of crouching frame here first. And from that it goes into sort of a jumping. You can see 3 frames here are like the wind flowing and being in a jumping state. Then we sort of transition into something that's falling. And when we reach approximately here at frame 12, we're falling. And then we're entering some kind of landing phase there. So this jump actually has a bunch of different states in it. And how I came to this is I checked through this and this is what I got from it. So we have a starting of jump at frame 0 or sprite 0. Sprite 1 to 3 is us jumping. 4 to 11 is a transition from jump to falling. 12 to 14 is us falling, and 15 to 18 is a transition into landing essentially. So what we're going to be doing is we're going to be, you might want to write these down potentially, but what we're going to be doing is we're going to be making some new sprites from this jump sprite collection to make sure that we have all the different individual parts of this jump so we can make it more fluent and more dynamic. Because like we saw, the problem with this type of jump is that we go into the jumping and we do the animation either looping multiple times, or it doesn't finish, or we finish early and it won't look good because we enter sort of the ground too early. So it's not as dynamic depending on if you're doing a long jump or a high jump or a short jump. We want it to be fluid and adapt to the situation. So starting off, we'll right click on sprite 0, we'll create a flipbook. We will call this one start jump. We will then take sprite 1 to 3, right click, create as flipbook, and we will say jump upward, just to keep it different from the actual jump sprite that we had originally. You could either remove this one and rename it to just jump if you want to, but I'm going to be doing this for now. So it might make sense for you to follow along like I do and then rename afterwards when you understand. 4 to 11 will be our transition. So 4 to 11, right click and flipbook, and we say jumping to fall. And then we had 12 to 14 is falling. So we'll find 12 to 14, which is these. Create flipbook, falling. And lastly, we should have 15 to 18, which should be the transition to landing. So we'll just call it landing. So now we created all the different flipbooks that we need. We'll save it so we have all of them. Now we need to create our animation sequences for them. So what we can do is we can go to animation sequence and we can do a duplicate on the jump, for example, and call this jump start. We can open it up and change it to the flipbook that's called start jump. Then we can duplicate that one and call it jump upward. We open up that one, call it the jump upward one, like so. We'll duplicate again. This will be the jump to fall animation sequence. So we jump to fall, and then we duplicate again. And this one will be the actual falling one. Open up that one, we'll get the falling one. And lastly, we'll duplicate again, and we'll call this one fall. Now we'll call it landing. And then we open that one up and choose the landing one. There we go. So now we should have all the different animation sequences that we need. We can make sure to save everything again. And they're all split up now in different parts. So if we open them up, we can see we have the falling one, we have the jump start one, we have the jump to fall one, we have the jump upwards one, and we have the jump downwards, no, falling one, sorry, that's one. And then we have the landing one. So now that we have these different pieces, let's put them together into something that looks okay. So we have this transition over here. We can actually move it out of the way and just skip it for now, so we see that it's a separate thing. And we'll do instead a new state, which we will call F2 to rename, and then we'll call this jump. We'll create another state, and we call this one falling. So what we want to do here is we want to, like we did before, get to our jumping situation. So we'll drag off to our jump, and we can get the same parameters or code that we had from the old jump actually. Or you could just reuse this if you want to, but I wanted to separate it to make it a bit clear here what's going to be happening. So now we should have the transition to jump, and we could add the transition back to idle again if we wanted to. So if we do that and demonstrate, we can get the same code here. We'll just get this one and copy it and put it in here, like so. Now we should have the ability to jump and get back to idle. So let's test it out. Also, before we do that, we should disconnect these by pressing delete, so we don't actually have a conflict in the different states. There we go. So now we play and we press, and you can see we're jumping up, but nothing is happening. The reason for this is because I forgot the states. So we're going to jump and we say play jump upward, because that's going to be our upwards jumping animation. So, and we try again, and we play. We can see that we're playing it, and we're stopping when we're landing, but we're playing the same animation up as down, but we have a falling animation, so we want to make use of that as well. So how can we do this? Well, we need to transition from jump to falling. That much is clear. And how do we decide when we're falling? Well, we can do something similar to what we did when we were transitioning from idle to running, because we're going to be deciding that we're falling downwards, meaning we have a negative speed in the Z direction. And here we checked against having a specific speed, or having a lack of speed, or having zero speed in an X direction. So we can essentially take this code if we wanted to and go into this transition from jump to falling. And here we could check if Z is going to be less than 0. And if it is, then we are falling. Also now, since we have a reference to our player character, we don't actually need to get actor here. We could replace all of these with get player character reference like this. To test this out, we can see we can jump up and we fall down, and you can see it breaks in this case because we didn't finish the actual animation blueprint here, because we have this transition but we don't have an animation for falling, so we need to add play falling. And in addition to that, we also end up in a situation where we get stuck in a state. If we just do this, because we don't have a state to return from falling, this is the end state we have. But we probably want to go back to idle if we have finished falling, essentially. And we can use the same transition that we used over here, where we just check against falling, like so. And add it here, like so. Compile, save, go back to the state machine, and we removed one from jump to idle, because we don't want to go from jump to idle anymore. We want to go through the jumping, the falling, and then back to idle. So how does this look? We play, we jump, we have two different animations, one for going up and one for going down. It's already looking much better. But now we get to the point where we can actually make something look a little bit nicer transitionally. And this is by making use of something called just that, transitional animations, you can see up here. So on these transition rules, we can actually add the possibility to add a transitional state. To make this very clear, we can go to the idle to jump one, and we can click this, and we can say we want to open anim graph, and here we can place that animation. The difference between this and the normal state is, or for the most part, is that it plays once. Or not for the most part, it does play once. These are one-shot animations, and states are looping animations. So in the animation graph here, what we want to do is we want to play, and we had a start jump, I believe I called it, jump start. And we put that in. And this was just our 0 frame that was essentially the character kneeling. So if we press it now, you can see maybe you get this short little, it's bending down before it's jumping. So you get the feeling of the character doing an effort of jumping off from the ground essentially. So that's already making it feel more fluid and alive. Let's add to this another transition from falling to idle. And let's add a transition element here and say that we want to play the landing. And it's like so. And then we compile and run. And you'll see that now we'll have this sort of bending the knees as we land to absorb the shock of the fall essentially. So how do these work? Well, a transitional state with an animation works in this way. If you're going from idle to jump, meaning that you've fulfilled the transition rules, which in this case we just have this jumping boolean, then you will first do this transitional animation before you end up in the loop, or the looping animation that's in the state. However, this only remains true as long as this is the state that you're decided to be in. If you, for example, immediately start getting negative speed downwards, essentially falling off a cliff, then this would not happen. If we were to actually, we could probably demonstrate this. No, we can't, and we'll get to that in a moment as well. We would, if we go from idle to jump, but jump immediately identifies that we're falling downwards, then this state is no longer true, which means that this transitional animation will abort or not play if this immediately gets false, essentially, or transitions. So that's how they work. They will only play as long as the state they're transitioning into is still true. If the state they're transitioning into transitions into a different one, then they stop playing. So it might be a bit hard to get around, but hopefully we'll be able to work that out. One thing that we might have you noticed with the last time we ran was that we have an issue here already, and that is this only works when we're in idle. To demonstrate it more fully, let's jump down from this pillar. So if we're standing idle and we're jumping, we're getting into our animation and it looks fine. But if we're running and jumping, it continues the jumping, or the running animation, because we don't have a transition available to go to jump from running. So if we wanted to do that, we would need another transition over here. We would have to go in here, we would have to get this code, and we can go in here and we can add to this. We also wanted to do this transition when we're doing it running. And now if we're playing, you can see that when we're running and pressing jump, we're doing the jump animation as well. So this is already starting to get a bit cluttered. You can see we're getting a lot of arrows. It might be difficult to follow, and it would be even more complex the more we went along with this and added more states. We'll get back to that in a bit. But another thing I want to show here now is that when we're doing the jump, when we're running, so we're running, jumping, you can see that it won't play the state or the transition for the landing. Because once we get to falling, we want to do the transition to land, but we're not idle. We are immediately identifying that we're running, which means that this state aborts and we go into running instead. So that's how this is visualized for us in this case then. Hopefully that makes sense now. Now, of course, we still have one more animation transition that we could make use of, which is the one between jump and falling here. So we can actually go and make use of that one as well. And we will call this play jump to fall, I think. Yes, jump to fall. Hook that up, like so. Compile, save, and you can now see that we're going to be getting a animation change when we're jumping, and then it transitions between. Before it goes into falling, it will do the animation that transitions into falling, which is actually fairly long in this case. So this would look nice if we jumped off something fairly large, like this pillar that we have created. So we jump up and then we fall over the edge just, and you'll see it transitions into the falling and it looks nice, and then we land and it does the absorbent animation. So that all looks good and fine now. So now we should have a handle on the transitional animation states. Now might be a good time to look back at the problem we ran into earlier, which was that we're starting to get a lot of different arrows here, making it a little bit difficult to follow and having multiple transitions for different states and such things. There is another node available to us that can alleviate situations like this, make it a little bit cleaner depending on what kind of situation you have. So to demonstrate this, we right click and you can see we have a jump node. Now the jump is not supposed, or you shouldn't mistake this for the jump that we have been having here and up here and stuff like that. A jump node is essentially a sort of node which we can force our animation state to go to based on different circumstances, and we can cause this to happen in code, for example. So let's rename this first, and we can call this jump activated. Now the point of this one is supposed to be, we want to, when something happens, we are supposed to decide that a jump has happened, and then we want to run into our jumping states here. So we could do something like this. We could create another state here, which we can call, let's call it start jump. So start jump, we can transition into from our jump activated, and then we can say from start jump we're supposed to go into jump, and from there we're supposed to go into falling, and from there we're supposed to go into idle, for example. So what we can do now is essentially we can cut out the transition from idle to jump and the transition from running, is this the right one? Running to jump, this one. So now we only have this graph. So idle can go between idle and running, but then at some point we can cause the jump activated state to happen, which goes into start jump, goes into falling, and goes back into idle when it's landed. So for start jump here, we could have our actually let's do this. So what I want here is, because we have eliminated the branch we had here before, essentially what I want to do here is between start jump and jump, I want to have the transition, so we can go with the start jump animation sequence like this. So that means that as long as this is true, we'll play this first when we get called here, but we don't need to have an actual animation in here at all, I think. We'll be fine without it. Because we can go into the start jump here, actually this transition is what I'm after, and say immediately that we want to transition true, regardless of what's happening, because we have decided, we have decided already here that we are jumping. So this is just for the start jump to give us the transition, which will allow us to transition as long as we're jumping. But if we're not jumping, instead, if we're falling off a ledge, then this will not play, because this is getting passed immediately, because this transition says that we're falling, negative speed essentially. So this is the whole idea of this, and we'll get a little bit back to this and make it a little bit clearer in a moment. For now we need to actually activate this forcing of state. We can do this in our character, and we can say, basing on our animation component, we can get our animation instance. And our animation instance allows us to use a function which is called jump to node. There we go. So this function here needs to have a jump name and possibly a state machine if you have different ones. We only have one, we don't have to fill this one out, so we just need a jump name. So we can go to our animation blueprint, make sure that we get the name, so we copy it over here, place it over here, like so. So now we can theoretically call this and enter that state whenever we want. But when would we want to join or enter it? Well, we have an event jump. So we could use this one, and since we are no longer checking against our jump boolean, because we have removed that code, because we're now entering the jump state from here instead, which is code instead of the boolean, we can actually now get rid of this. Then we can say, okay, well, if we press jump, which again, this function or this event gets called when we're actually jumping up here. We're entering the state. The state should go in here. It should immediately transition and say play the transition animation. We should go into jump. Let's test it out. So we jump and everything looks just like it did before, right? So everything is fine. And if we're running and pressing jump, you can see that we're still playing the animation because our code here is not taking into consideration if we're standing still or if we're jumping, which means that we can bypass the whole problem of having multiple transitions into the jump here, which cleans it up for us a bit. We do have a problem though. If we go over this edge of this box, you can see that we're just running. We're not actually falling like we want to. There is a nifty little function for this, or an event, which is called, I think it is actually walking off edge. Yes, walking off ledge. There we go, and we can hook that up as well, and we can say that if this happens, we're also supposed to go into the jumping. Compiling, you can see that when we do that, we enter in, we don't have the jumping animation, we have immediately the transition from jump to fall, then the fall, and then the landing. Which gives us a very clean way of having the animation. So by having it structured in this way, with the different states and their different transitions, we get a jump that works both if we're jumping or if we're falling off. And it is dynamic in its length, so it doesn't matter how far the fall is, essentially. It will look good regardless. So that is essentially all we wanted to go through in... No, actually, one more thing. Since we have, in this case, we have checking against our walking here, we can actually clean up our code a little bit by going back to our character. We can remove this on landed, setting the jumping because we don't need it anymore. So we can remove this event completely if we want to. Put this back here and remove this boolean because we don't need it. And everything should be working fine. We can jump, we can run and jump, and we could fall off if we wanted to. So much cleaner. So that is all I wanted to go through in this a little bit more advanced version of the animation states. And to go through briefly what we have done. We have learned about the transitional animations. Our transitional animations are animations that are played once and they played between the transition of different states. So when a state has been determined that you want to transition to it, its transition animation gets played once. However, it's only true as long as the state you're trying to go to is still a stable state. Its transition rules have not been fulfilled. If it does, the transition of the previous state gets aborted, and if this one has a transition state instead, that starts playing before it then goes to the state and starts playing the looping animations. Then we have also gone through our jump nodes in the animation graph, which allows us through code to force us to jump to a specific part in our animation state, which allows us to avoid having so many crisscrossings of animation states, transitions, which makes it a little bit cleaner. And of course we could have a transition to running and idle, but it isn't necessary, because if falling goes to idle and idle immediately determines that it is running, then it's just being bypassed. So we only need one arrow back to our normal state, so to speak. Anyway, I hope that made sense and you learned a lot. That is all for now. Keep on learning. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.